Okay, geometry students, in this video we will start our journey into studying two-column proofs, and so these will be pretty difficult to do, a lot of difficult math, so I hope that you'll really pay attention and take some really good notes, okay? Let me see if I can get this thing to work here. Hold on one second. Alright, there we go. Okay, your heading today is called Two-Column Proofs, Lesson 2.5. Please copy this in your notes if you would, please. And include today's date. Alright, so Two-Column Proofs, Lesson 2.5, and please include today's date in your notes. Please copy this in your notes. Okay, moving on. We first need to look at some properties that are pretty much common sense, but very important in two-column proofs. It's math that you've known pretty much your whole mathematical life, but we really need to go over these and just review, okay? So, I would like you to turn in your books to page 84, and when you do that, you're going to see this box right here in your books. So I'm going to pause for about 30 seconds here, or 20 seconds, and go ahead and turn in your books, if you would please, to page 84. And we're going to talk about these properties for a couple minutes. It's really important that we talk about these, that you understand what each property stands for, and then we're going to use these a lot this year when we're doing our two-column proofs. Okay, please turn your books to page 84. And I would recommend in your notes that you simply just put page 84, properties, something like that would be fine. And then maybe take some side notes if you want to about this information. Okay, here we go. Properties of equality. Well, first of all, it says let A, B, and C be real numbers. Now, you don't need to know this one, okay? But what it's saying is this. It's saying that all the properties down through here that we're getting, let me change colors of ink here. It's saying that all the properties we're getting ready to look at down through here are dealing with what letters? A, B, and C. And we have to state at the very beginning that A, B, and C are real numbers, not imaginary numbers, okay? And those of you students who have only had Algebra 1, you might not have gotten into imaginary numbers yet, which is fine, okay? Okay, let's continue on. Let's talk about a property called the addition property. The addition property. And here's what it says. Please look carefully, students. If A equals B, then A plus C equals B plus C. Now notice what we did. We added C to both sides. Now students, we've done that since you've been, in whatever grade, when we've had 2x minus 3 equals 5. Remember, in order to get rid of that negative 3, you would add what to both sides? Would you not add 3 to both sides? You should remember that from Algebra 1 or Algebra 2. Well, when you added 3 to both sides, you were doing the addition property of equality. And I wish they had that written. It should say addition property of equality. Notice here it says properties of equality. It's very important that you notice that. Is everybody listening to me? Because all of these properties here are dealing with equality, not congruency and not inequality. So it's very important you see that. I would make a note of that somewhere, okay? All of these properties here are properties of equality, okay? So the addition property is just saying we add the same number to both sides. That's all that it's saying. So with that in mind, you can probably guess what the subtraction property is saying. A equals B, and then look, we subtract C from both sides. And both sides are still equal. Look guys, we've done this your whole life. Again, if I had 2x plus 3 equals 5, to get rid of this positive 3, you would subtract 3 from both sides. You guys know that. And when we did that, the equation was still equal, okay? And so you can subtract the same number from both sides, okay? That's totally legal in mathematics, all right? So we have the addition property of equality, and that's simply where you're starting off with A equals B, and then you add the same number to both sides. And then we start off with A equals B, and we subtract the same number from both sides. And obviously, because of subtraction, we call it the subtraction property of equality. Now, this is common sense. Look, if you have A equals B, and you multiply both sides by C, then both sides stay equal because you're multiplying this side by C, and you're multiplying this side by c. And so obviously we call that the multiplication property of equality. Okay, look at the division property of equality. You know what it's going to say. It's common sense. You already know what it's going to say. It starts off with A equals B, okay? And then we divide both sides by C. We divide this side by C, and we divide this side by C. So both sides still stay equal. If I have 8 equals 8, let me get a drink here real quick. And I divide both sides by 2, the same number, I get 4 equals 4. If I start off with equal numbers and I divide both sides by the same number, I'm going to end up with still an equal statement. And that's called the division property of equality. Okay? So we have the addition, subtraction, multiplication, and division property of equality. Addition is when you add the same number to both sides. Subtraction is when you subtract the same number from both sides. Multiplication is when you multiply the same number to both sides. And division is when you divide both sides by the same number. And that's really, really easy to remember. So these are called properties of equality. Now, let's take a look at some interesting properties here. Reflexive property. This is basically a common sense property, and it's really funny, but they're saying if you have a real number A, then we can state that A equals A. Well, of course, again, I say, duh, obviously. So that's a pretty simple, easy property. The reflexive property, that means you can state that 2 equals 2, or 3 equals 3, or 50 equals 50, okay? And that's pretty obvious. And you can remember that because when you look in a mirror, you see a reflection of yourself, and so it's the reflexive property. It's like a mirror image of both sides, okay? All right, let's take a look at the symmetric property. Symmetric property says if A equals B, then B equals A. And again, that's pretty much a duh type of property. It's really simple. I mean, if 2 equals, 4 over 2, which is true, then I can also say 4 over 2 equals 2. All right? Or if you want to use equations, if I said 2x equals 5, that would be the same thing as 5 equals 2x. Okay? And we call that the symmetric property of equality. Okay? All right. Now, let's take a look at the transitive property. Now, this one's a little different. Okay? If A equals B and B equals C, then A equals C. Okay? If A equals B, so they're the same, and B equals C, then A definitely equals C. And that should make sense to you. If I told you angle A equals angle B, and then I told you angle B equals angle C, well, look, if angle A is 30 degrees and B is 30 degrees, that means that C is going to be 30 degrees. I can definitely state that angle A equals angle C. And that's called the transitive property of equality. If A equals B and B equals C, then A equals C. All right? And then last but not least, obviously, if A equals B, then A can be substituted in for B. And we know that. Look at that again. If A equals B, then you can substitute A in for B because A equals B. And students, again, we've done that your whole mathematical life, and we have an expression like 2x plus 6, and we say x equals 3. We know that where the x is, we can substitute 3. And of course, you would get out 12. 2 times 3 plus 6. And so that's what the substitution property is saying. If A equals B, then you can put A in for B, or you could put B in for A, for that matter. Okay, now let me drill one more thing into your head here you need to see. Please listen to me, students, and don't miss this. Again, these are all properties of what? Properties of equality, not properties of congruence, and not properties of inequalities. We're going to get to some of those a little later, okay, during this video. These are called properties of equality, okay? All right. You need to be very familiar with those and know those very well for tests and quizzes. Okay, let's continue on. Now, notice that all of the properties had equal signs, okay? They were properties of equality. Let's take a second and let's talk about inequalities and properties. So we were just looking at equalities and properties, equal signs. Now let's take a second and talk about inequalities and properties. And again, I will tell you when you need to write something down, and right now just sit back and listen, okay? The reflexive property, A equals A, you don't need to write this down unless you want to, but you don't need to. It cannot be used with inequalities. The reflexive property cannot be used with inequalities because it would look like this. You would say A is less than A. Well, that's not true. Or A is greater than A. Now you can say that A equals A. That's totally fine. But you can't say A is less than A. They're the same thing. You can't say A is greater than A. They're the same thing. So the reflexive property would not work for with inequalities, okay? The symmetric property, I'm not sure why I didn't put that. The symmetric property can't be used. I forgot to put can't be used. The symmetric property can't be used either with inequalities because here's the symmetric property. Look, if A equals B, then B equals A. So now let's try this with inequalities. If A is less than B, then B is less than A. That's impossible. If A is smaller than B, then we can't say B is smaller than A, okay? So the reflexive property cannot be used with inequalities, and the symmetric property cannot be used with inequalities. I mean, I've just showed you right here it can't be done. But take a look at this. I would like you to write this down. The transitive property can be used with inequalities. Okay, remember the transitive property is this. I'll take some good notes on this. If A equals B and B equals C, then A equals C. Okay? Well, look, let's try this down here. If I said A is greater than B and B is greater than C, then A is greater than C. And that's true. Think about it. Let's use numbers, okay? Let's say 8 is greater than 3, okay? So we're just picking random numbers for A and B. We'll say A is 8 and B is 3. So I come over here and I say 3 is greater than 1. We'll say C is 1, okay? So 8 is greater than 3. 3 is greater than 1. Well, 8 is definitely going to be greater than 1. This number here will definitely be greater than this number here. So if A is greater than B and B is greater than C, then A is greater than C. So we can not use the reflexive property with inequalities. We cannot use the symmetric property with inequalities. However, we can use the transitive property with inequalities. Okay? All right, let's continue on. Now, just for a minute, I need to pause and talk about the word congruent. And I will tell you when I need you to write stuff down. All right? In a general sense, two objects are said to be congruent if they have the same shape and size. For example, if the measure of angle A is 30 degrees and the measure of angle B is 30 degrees, then we say what? We say angle A equals angle B. Well, usually we say the measure to be proper. We say the measure of angle A equals the measure of angle B. But what else do we say? We also say angle A is congruent to angle B. Okay, in fact, the definition of congruent angles is when two angles have the same measurement, they're congruent. And so in a general sense, two objects are said to be congruent if they have the same shape and size. We know that, okay? Now, since congruent and equal are basically the same, you can also use congruent for the reflexive, symmetric, and transitive properties. So let's review, okay? You really need to pay attention, students. Watch. Let's review. All of these properties here are properties of what? Equality. That means we're using equal signs with all of these. And then we talked about the fact that we can use inequalities. We can use inequalities for one of these properties, transitive, okay? And now we're looking at congruence, and we're saying this. Congruency can be used for reflexive, symmetric, and transitive. Now notice we did not say that congruency could be used for these. We did not say congruency could be used for the addition property or the subtraction property or the multiplication property or the division property. You can't. You cannot use those with congruent symbols. You cannot say 2x is congruent to 6, so I'm going to divide both sides by 2. You cannot divide both sides by 2 unless you have a what sign right there. It has to be an equal sign, okay? If it's a congruent sign, then you can't do it. So understand, you can use congruency for reflexive, symmetric, and transitive. Now I know this is a little confusing, but hang with me, take some really good notes, and I'll explain this, okay? All right, so here we go. Let's look at this again. We can use congruence for reflexive, symmetric, and transitive. And these properties are called the properties of congruence. There are 3 of those, okay? So in your notes, I would like you to write this. 3, and I should have typed this, I apologize. 3 properties of congruence. 3 properties of congruence, okay? And here they are. Here's number 1. Here's number 1, the reflexive property of congruence. A is congruent to A, and that makes sense. I mean, A has to equal A is congruent to A. Here's property number 2, the symmetric property of congruence. The symmetric property of congruence. If A is congruent to B, then B is congruent to A. To me, that's common sense. Please write these down. Property number 3, the transitive property of congruence. The transitive property of congruence. If A is congruent to B and B is congruent to C, then A is congruent to C. Now I've gone pretty fast through these 3, so I'm going to pause for a second and let you get caught up, okay? The reflexive property of congruence, the symmetric property of congruence, and the transitive property of congruence. So these 3 properties here can be used with equal signs, and they can be used with congruent signs. This one here, transitive, can be used with equal signs, congruent signs, and inequalities. You might want to, I'm going to pause for a couple seconds while you organize your notes. You might want to write some of that stuff down there. That's real important, okay? Again, these 3 properties can be used with equal signs or congruent symbols. Transitive can be used with equal signs, congruent signs, or inequalities. Okay, let's move on. Here we go. All right, we are going to finish up this video looking at proofs. First, though, I want to quickly do an activity that I think will really help drill these properties into your head and help you understand them. So if you would, please, I want you to turn your books to page 87. Please turn your books to page 87. You may work ahead, but if you do, be sure to check your answers. We are going to look at numbers 1 through 10. So if you choose to work ahead, that's fine, although I don't recommend it, but that's fine. But make sure you check your answers, okay? All right, here we go. Please turn your books to page, whatever I said, page 87, and we're going to do numbers 1 through 10. I'll wait a couple seconds here while you get your books open. Okay, here we go, students. Let's see if we can't figure these out. Here we go. Look at number 1. We have JK congruent to JK. Now, the first thing I want to point out to you is this. We have a congruent symbol. Do you see that? So the property we're looking for over here has to be a property of congruence. So it's either going to be D or G or I. Now, we have JK congruent to JK. That would be like A is congruent to A. JK congruent to JK. So that's going to be the reflexive property of congruence, which is letter G. Letter G. All right. Let's grab this here, drag this down here, and cross this off. Letter G. All right. Let's take a look at number 2. Now notice we're dealing with equal signs. Okay. So whatever property we use here, it's going to be a property of equality. All right. And here we go. JK equals PQ. PQ equals ST. Then JK equals ST. So JK equals PQ equals ST, so JK equals ST. That's transitive, and that's going to be the transitive property of equality, letter E. Transitive property of equality. Okay, number 3. The measure of angle S equals 30. Now look here, watch carefully. The measure of angle S equals 30. Then, look what we did. We added 5 to this side. And notice how your 30 right here became a 35. So we added 5 to both sides, okay? So if we added 5 to both sides and we're dealing with equal signs, that's going to be the addition property of equality. We added 5 to both sides, okay? Let's take a look at number 4. Now notice we're dealing with congruencies. Congruent, congruent, congruent. And so because of that, we know we're either going to have either D or I, one of those two. Okay, so here we go. Where were we? Okay, if if Q is congruent to R and R is congruent to Z, then Q is congruent to Z. So Q to R, R to Z, Q to Z. That's going to be the transitive property of congruence. The transitive property of congruence, which is letter I. Okay. All right, let's take a look at this one. AB plus AB equals 2AB. Now that's interesting. I'm not sure. Let's come back to that one. Okay, let's come down here. AB equals AB. Now we have an equal sign, so we know we're dealing with an equality. Okay, and it's AB equals AB. So that's going to be the reflexive property of equality. Letter B. The reflexive property of equality. Okay, number 7. If ST equals 2, okay, and SU equals ST plus 3, then SU equals 5. Now watch what they did, students. What does S2 equal? 2. So what did they put in for ST? They put in 2. And 2 plus 3 equals 5. So they made a substitution. They substituted 2 in for ST. And notice we're dealing with equal signs. So it's going to be the substitution property. Let me get rid of this real quick. It's going to be the substitution property of equality. And here it is right here. Letter C, the substitution property of equality. All right, actually it's right up here. You can't see it, but it's the letter C. Okay, number 8. If the measure of angle K equals 45 degrees, then 3 times the measure of K is going to equal 135. Now look what they did. They have measure of angle K equals 45. We multiplied this side by 3, and we multiplied this side by 3. So we multiplied both sides by 3. So that should be the multiplication property of equality, which would be letter H. Okay, let me get a drink here, and let's continue on. If the measure of angle P equals the measure of angle Q, then the measure of angle Q equals the measure of angle P. Well, first of all, we're dealing with equal signs, so we know it's going to be an equality property. Secondly, whenever it's A equals B and B equals A, we call that symmetry. Okay, symmetry. So what we're looking for is the symmetric property of equality, which would be letter F, the symmetric property of equality. And then number 10, if angle EOF is congruent to angle COE, then angle COE is congruent to angle EOF. So first of all, we're dealing with congruent symbols. So we know that it's going to be one of our congruence properties. And then number 2, they simply took this angle here and this angle here, and they swap places, and we call that reflexive. So it's going to be the reflexive property of congruence, which is letter D. Or symmetric, I apologize, it is symmetric, and I knew that. The symmetric property of congruence, okay? And then lastly, the distributive property, and that makes sense. AB plus AB is 2B. In classes I've taught in the past, we called this just simply simplifying. If you have AB plus AB and we put 2AB, we just call that simplifying. I really don't care if you call it distributing or if you call it simplifying. Either way is fine, okay? All right, now let's continue on. We're going to look at 2 proofs now, and they're going to be pretty challenging, okay? So be ready for that, and then we're done with the class period, okay? So here we go. Let's go ahead and do our first two-column proof or argument. Usually they're called two-column proofs, but this book also calls them arguments, okay? Now, it's very important on your first two-column proof that you just take notes and listen. Don't try to work ahead. Don't try to figure this out. It's really, really difficult to do. Okay, so here we go. Copy this in your notes if you would, please. I want you to copy this angle here and then put this angle bisector right here. And we have a C and a B and a A and a O. And we're going to call this angle here angle 1. And we're going to call this angle here angle 2. All right. And then go ahead and write down your given, and I'll explain what that is in a second. The measure of angle AOC equals 50, and the measure of angle 1 equals 25. Now that's what you're given, that's what you know, okay? And here's what you're trying to prove. You're trying to prove that ray OB bisects, bisects angle AOC. And once again, students, I advise you to just really take notes and don't try to figure this out. Just take notes and listen and write down what I tell you to write down, okay? And so here we go. Let's go ahead and try to do this two-column proof. Now here's what you do. When you are asked to do a proof in geometry like this, what you want to do first of all is you want to go ahead and set up a table like this, okay? So you're going to want to put the word statements over here, and you're going to want to put the word reasons over here. So go ahead and do that, okay? And what you're going to do is really simple. Every time you make a statement over here, you put a number and you make a statement right here, you have to give a reason over here. So you're defending every statement that you give, okay? And that's what you're trying to do, all right? So now, the best thing to do when you're dealing with a proof like this is to brainstorm and just kind of think through what you're going to do. So let's go ahead and pick up our given. We are told that we know for sure that angle AOC equals 50. So I know this whole angle right here is 50 degrees. If you want to write that on the on your picture, you can. You don't have to, but you can if you want to. And I'm going to make note right here that the measure of angle 1 right here is 25 degrees. I'm going to squeeze that in here, 25 degrees. Now we're going to have to brainstorm, okay? So here we go. Let's think this through. Here's what I'm thinking. I know that I can take angle 1 plus angle 2, and I know that's going to equal 50 degrees. Everybody should be able to see that. If we take this angle here, angle 1, and angle 2, and we add those together, we will get 25 degrees, right? And we know that the measure of angle 1 right here is 25 degrees. We know that. And so we know that we can substitute 25 degrees right here. And then we can subtract 25 from both sides, and we'd be left with angle 2 equals 25 degrees. Now again, I'm not asking you to have thought of any of this yourself. I'm just simply saying to you, I'm just brainstorming and thinking this through. I mean, it does make sense that if the whole angle over here is 50 and this angle here is 25, then angle 2 has to be 25. And if angle 2 has to be 25, then obviously OB has to be a bisector. It has to cut the angle in half. So with all of that in mind, I'm just trying to think of a way to prove this. So again, I'm not asking you to be able to do this on your own on the very first day, or for that matter, even many days from now. But I do want you to write down what I write down over here. Okay, I'm back, students. Sorry, my voice is really bad. Okay, so here we go. Here's what you always do in a proof. Please take some really good notes. The first thing you always do is you write down your given. That's the first thing you always do. So the measure of angle AOC equals 50 degrees. Please write that down. And then you write the measure of angle 1 equals 25 degrees. And then what is your reason for that? You put the word given. Students, that's the first thing you always do. So that's easy. You know, on a test or a quiz, every student can do that. So that's one step right there on a test or a quiz that you got right. Always put the given in first, and your reason would be the given, okay? Now, I'm trying to think of something I can do, but everything I write over here, I have to have a reason over here. So let's go ahead and write this. Let's go ahead and write, let's see, let's go ahead and write the measure of angle 1 plus the measure of angle 2 equals the measure of angle AOC. I can do that. The measure of angle 1 plus the measure of angle 2 equals the measure of angle AOC. And the reason I can do that is called the angle addition postulate. Okay, that's the postulate we learned earlier this year. It's called the angle addition postulate. You can just put angle addition. That's good enough for me. Okay, so we can do that. Now, hey, remember your properties. Let's go back here really quick. Let's go back here real fast. Remember your properties right here, way back here, right here. Remember you had a substitution property, and you can use your substitution property as long as you have what signs? Equal signs? Well, I have equal signs. Look what I have. I have 1 plus 2 equals this right here. And look at number 1. I have the measure of angle 1 equals 25. So I can substitute 25 in for the measure of angle 1, because look right here, the measure of angle 1 equals 25. So where the measure of angle 1 is, I'm going to put 25 degrees. Now you should be totally lost right now. That's totally normal. Just take notes and just watch, and we'll do a bunch of these throughout the year, and slowly but surely you'll learn how to do these, okay? So where the measure of angle 1 is, I substitute 25 degrees. So my reason would be substitution property of equality. Do you see how I just abbreviated? Substitution property of equality. Okay, number 4. Now, notice I have an equal sign here. And if I have an equal sign, I can use the subtraction. Well, I could have made another substitution. I'm very sorry about that, students, but I could have made one other substitution here, and I should have. You can do it all in the same step here because your reason is substitution. Right here, students, the measure of angle AOC, the measure of angle AOC equals 50. So where this angle is right here, I can put 50 degrees. Okay, sorry about that. And I can do that on one step because my reason is the same, substitution property. Now, what if I subtract 25 degrees from both sides? If I subtract 25 degrees from both sides, on this side it's gone. Over here, 50 minus 25 is 25. So my reason for doing that would be the what? The subtraction property of equality. I subtracted 25 from both sides. Now, be really careful here. Look at this. What does the measure of angle 1 equal? 25 degrees. Do you see that? The measure of angle 1 equals 25 degrees. So where this 25 is right here, I can make another substitution, and I can put the measure of angle 2 equals. Now look, students, right here, the measure of angle 1 equals 25 degrees. So where 25 degrees is right here, I can put the measure of angle 1. I made a substitution. For 25 degrees, I put the measure of angle 1. So what I have now for my reason would be the substitution property of equality. Now look, students, you're like, oh, Mr. Earhart, you did it. You stated, now look, students, you stated that angle 1 equals angle 2, didn't I, right here? Yes, I did. But hold it, we still cannot say that OB bisects this entire angle. We cannot say that because remember, I know it gets really annoying in geometry. There's a lot of little things you got to remember. But look, remember the definition of an angle bisector is a ray that divides the angle up into congruent angles. And right now we don't have congruent angles, we have equal angles. So what you need to do next is you got to state the measure of angle 2 is congruent to the measure of angle 1. And are you allowed to do that? Yes. Remember the definition of congruent angles. We learned a definition earlier Students, we learned a definition earlier this year that said when two angles are congruent, their measurements are the same. So if two angles have the same measurement, we can say they're congruent. And now look what I can finally state. I can finally state this. I can finally state that ray OB bisects angle AOC. And what's the reason? How do I know that? Well, it's called the definition of an angle bisector. Remember what the definition is? The definition of an angle bisector is a ray or line or something that divides an angle up into two congruent angles. And I just stated right here in step 6 that we have two congruent angles right here. And so if I've stated these two angles are congruent, then I can definitely state that this ray right here is an angle bisector. Now, usually, the first time a teacher does a proof in class like this, there's not one student who gets it, and so that's very normal, okay? All that we're trying to accomplish today is one thing. Just take notes. Just take notes and get used to this. Take notes and get used to it. And little by little, as you do more and more of these, you'll be able to start doing some little proofs on your own. Okay, let's do one more, and I just want you to take notes, listen to me, and we're going to take this really slow. And trust me, students, on tests and quizzes, I'm very fair and I'm very reasonable on how many proofs I give you and how I grade them, okay? So don't worry about that, okay? Well, let's take a look at another proof, and then we'll be done with the video. Okay, students, let's try another one. I'd like you to copy this in your notes if you would, please. We have segment AD, which has points B and C over here. There we go. So if you would please copy this figure in your notes, and then go ahead and write your given. You are given that segment A equals segment CD, and you're trying to prove that AC equals BD. All right? So I'm going to wait about 30 seconds. Go ahead and copy this in your notes if you would, please. Go ahead and copy your given and your what you're trying to prove in your notes, and then go ahead and get your two-column proof all set up, okay? Go ahead and get your lines drawn and get the word statements written and the word reasons written, okay? Okay, now students, the first thing I guess we can always do is go ahead and write your given. So I'm going to put number 1. I'm going to put AB is congruent, sorry, not congruent. AB is equal to CD. And my reason will be it's given, okay? Now, after that, we got to brainstorm and come up with some plan of attack, how at the very last step down here, we're going to have what? AC equals BD. So the very last step that I have down here should state what I'm trying to prove, which is AC equals BD. Now, let's use some numbers. Sometimes numbers help. Let's see, AB equals CD. I'm just brainstorming right now. Let's just say that AB is 7, just for the fun of it. So if AB is 7, then CD has to be 7. And let's just say BC is 2. Now, they want us to prove that AC, and by the way, students, what is the length of AC? It's 9, isn't it? 7 plus 2. They want us to prove that AC equals BD. Well, the length of AC is 9, and the length of BD is also 9. So we know it's true. We just have to come up with some plan of attack, and I think I have it. I think what we ought to do is probably use our segment addition, and I think if we shouldn't have done that. I think if we use segment addition, we can do maybe some addition and some substitution, and maybe end up with this down here. So let's see, okay? I'm going to start off with this right here. Now watch carefully. I'm going to state that AB plus BC equals AC. That's right, I can say that. AB plus BC equals AC. Now write that down, okay? Then I'm going to state BC plus CD equals BD. And that's true. BC plus CD equals BD. And of course, the reason I can do that is called segment addition. Remember, we had a postulate called the segment addition postulate. Now you're probably saying, well, Mr. Arrowhead, how'd you know to do that? Well, I'm thinking, if I'm not really for sure, but I'm thinking if I can add maybe AB and BC and get a segment here, and then BC, a DC with BC, and add that, maybe I can subtract out BC, or subtract out maybe, I don't know, AB or AC or something, and maybe end up with this down here. Okay, that's what I'm trying to do. So we'll see how it goes. Okay, now let's do this next. Now, students, as I kind of study this, I notice this. I've got equal signs here, here, and here. So whenever you have equal signs, you're allowed to make substitutions. So AB equals CD. So see this CD right here? I'm going to go ahead and put AB. So for step 3, I'm going to put BC plus, and then I'm going to substitute AB for CD. So BC plus AB equals BD. So I took this out right here and I put AB in place of it, okay? And so by doing that, my reason has to be over here, substitution. Now students, look, I'm basically done, okay? I'm going to circle this in red. Please look. What do I have right here? AB plus BC. What do I have right here? Same thing. I mean, yeah, it's turned around a little, but that's not a big deal. I have AB plus BC, and I have AB plus BC. Do y'all see that? So I can make a substitution. AB plus BC equals what? What does it equal? AC. So what can I put in place of BC plus AB? I can put AC. And so for step number 4 right here, using substitution, for this whole expression right here, I'm going to put AC. So AC equals BD. And I did it. I'm done. That's exactly what I wanted to end up with right here. And my reason would be substitution. Okay? Now, students, I really need you to trust me. I know you juniors had me for a whole year in 8th grade math, and I know you sophomores never have had me before. But listen, you are very abnormal if you're totally getting this, okay? Most of you are going to be lost. You would have never thought to have done any of this on your own, or this over here, and that's totally fine, okay? All that I'm asking you to do is trust me. I'll be very fair and reasonable as we learn this stuff. And number 2, just keep doing these with me as I do them in your notes and as I give you some in your homework. And just keep practicing, okay? And you will get better and better at these as you go along, okay? All right. If you have any questions, don't hesitate to contact me.